Solving multi-step inequalities. Solve each of the following inequalities. Well, now remember, in solving inequalities, it's just like solving an equation. Follow the same steps. There is one difference, and that is when you multiply or divide both sides by a negative number, what do? You have to flip the inequality sign. So with that in mind, let's see how we solve these multi-step inequalities. Number one, we want to isolate the x. The x is what we're trying to get by itself. We need to get rid of the 3 and this minus 4. Start with the minus 4, cancel it out by adding 4 to both sides. 3x is less than or equal to negative 18. Now we're going to divide both sides by 3, and we get, as our answer, x is less than or equal to negative 6. In number 2, we're isolating the a. So we need to subtract 4 from both sides first. I have negative 19 is less than 2a. Now I'm going to divide both sides by 2. And I get as my answer, negative 19 over 2 is less than a. Now, for inequalities, and especially for inequalities, I want the a, or the variable, whatever variable I have, to be on the left-hand side. So I need to flip this thing over. So this would be a is greater than negative 19 over 2. In number 3, I want to subtract 12 from both sides of the inequality sign. I'll have negative 2n is less than or equal to negative 4. Now we should have noticed from the very beginning that in this particular problem, there is a negative attached to the n. That means in the end, I'm going to have to reverse the inequality sign. And in fact, I'm doing that here by dividing both sides by negative 2, reverses the inequality. I get n is greater than or equal to positive 2. In number 4, here again we have that negative attached to the variable. That tells us automatically, in the end, we're going to end up changing the inequality sign. Let's see what happens. I'm going to subtract 3 from both sides. I'll get negative 4x is greater than negative 16. I'm now going to divide both sides by the negative 4, and here's where the change comes. We get x is less than positive 4. In number 5, subtract 6 from both sides first. We get 1/2 x is greater than or equal to negative 8. Now I could divide both sides by 1/2. It's 1/2 times x, and to cancel out 1/2, I could divide both sides by 1/2. I don't like dividing by fractions, so instead let's multiply by the reciprocal. The reciprocal of 1/2 is 2. So if I were to multiply both sides by 2, that would give me as my answer x is greater than or equal to negative 16. And number 6, subtract 1 from both sides of the inequality sign. I'll have n divided by 7 is greater than negative 6. Now, this fraction bar means to divide. How do you cancel divide? Well, you multiply. What are we going to multiply both sides by? We're going to multiply both sides by 7, getting your answer of n is greater than negative 42. Now in number 7, in order to isolate the variable x, I need to get rid of the 2, this minus 4, and the divide by 5. The rule is, as I've explained before is to start with, of those three numbers that we need to get rid of, start with the one that's farthest away. Well, of the 2, the -4, and the 5 is farthest away. That's the one we're going to cancel out first. It says we're dividing by 5. Cancel divide, multiply both sides by 5. That 5 cancels out that 5, and you're left with 2x minus 4. So 2x minus 4 is less than 10 times 5, 50. Add 4 to both sides. You get 2x is less than 54. Dividing both sides by 2, we get x is less than 27. Now, what's different about number 8? What's different here is the fact that we have variables on both sides of the inequality sign. Well, the rule is that, at least for me, in my case, I always want to have my variable on the left-hand side of the inequality sign. That means I want to cancel them out on the right side. I always cancel, or at least almost always, cancel the variable on the right. We're either going to use addition or subtraction to cancel out the 11m. It's a positive 11m, so if I were to write minus 11m, they would cancel out. I'll come over here and do this underneath the 15m, and I get 4m minus 4 is greater than negative 16. And from here, I just merely add 4 to both sides. 4m is greater than negative 12. Dividing both sides by 4, I get m is greater than negative 3. Again, in number 9, I have variables on both sides of the inequality sign. Use addition or subtraction to cancel the variable on the right side. It's a positive 4x, so I'm going to go minus 4x to cancel it out. 2x minus 4x is negative 2x. Bring down the minus 6 is less than or equal to 7. Add 6 to both sides. Negative 2x is less than or equal to 13. Dividing both sides by negative 2 reverses the inequality sign, so it'll now read greater than or equal to. X is greater than or equal to, and again, I want to leave this as an improper fraction, negative 13 over 2. Page 2, again, solving multi-step inequalities. Each of these problems is incorrect. Find and correct the mistake in each. Well, let's look at number 1. Here's my variable that I need to get isolated. The 12 is positive, so I'm going to subtract 12 from both sides and get, oh, here it is right here. It should be negative 3x is greater than negative 3. And when we divide both sides by negative 3, it flips the inequality sign. That should read x is less than negative 1. In number 2, well, I have variables on both sides. Use addition or subtraction to cancel out the negative 3x. It'll take addition, so I could do plus 3x. And that looks okay. We have 15x plus 4 is less than negative 11. So let's subtract 4 from both sides. Get 15x. Here it is. It says 15x is less than negative 15, where somebody made this mistake and said greater than. Somebody flipped the sign, and we should not have. And when we divide both sides by 15, again, we leave it as a less than sign. So that should read x is less than negative 1. Now, number 3. Again, we want to isolate the x, get rid of the 9. It is a positive 9, so we are going to subtract it from both sides. I'll have the opposite of x is greater than negative 4, and here's the mistake. We don't want to flip it if we just subtract a number from both sides. We only flip the inequality sign when you multiply or divide by a negative. So this should have stayed greater than or equal to. Now, when we divide both sides by negative 1, that's when we should flip it and it should read x is less than or equal to positive 4. Well, before we get into solving story problems using inequalities, let's talk about certain phrases we're going to be seeing when you do solve inequalities. Some of the phrases that you're going to be seeing are things like is at least. Another one you may see is no more than. Another one you're going to see is at most. And another one is no less than. These are typical phrases you're going to see that we need to write inequality signs for. Well, is at least, let's think about that for a second. At least, the least it could be. The least it could be, meaning it could be greater or it could be equal to, but it can't be less than that. Is at least. So it could be greater than or equal to. Is no more than. How about that one? It can't be more than. It's not more than whatever. You can't have more than this. What does that mean? Can you have more than it? No. Can you have less? Yes. Can you have less or equal to? Yes, you can. Is no more than means less than or equal to. How about is at most? The most you can have is this. The most you can have is the most you can have is whatever. The most you can have. What does that mean? Can you have more than? No. Can you have less than? Yes. Again, less than or equal to. And then is no less than. What does that mean? You can't have less than this. Can you have more? Yes. Can you have that amount? Yes. Not less than. What does that mean? Greater than or equal to. So from now on, when we see these phrases in a story problem, these are the inequality signs we're going to be using. For example, number 1. 1/4 of a number decreased by 3 is at least 2. 1/4 of a number decreased by 3 is at least. Here's our inequality sign. Is at least. What does that mean? Greater than or equal to. So something's going to be greater than or equal to 2. 1/4 of a number, 1/4 times n, decreased by 3 is greater than or equal to 2. To solve this, add 3 to both sides. We get 1/4 n is greater than or equal to 5. Multiplying both sides by 4, n is greater than or equal to 20. Number 2 is greater than. Well, we know what that sign is. It's just is greater than. -4 times a number increased by 2 is greater than 10. -4 times a number increased by 2 is greater than 10. Now notice that the negative is attached to the variable. We're going to reverse the inequality sign at the end. So subtracting 2 from both sides, -4n is greater than 8. Dividing both sides by -4, n is less than -2. Is less than, obviously, is going to be the less than sign. 5 less than twice the number is less than 8 more than that number. 5 less than twice a number is less than 8 more than the number. 5 less than twice a number. How would we write 5 less than twice a number? Well, twice a number would be 2n. 5 less than that would be 2n minus 5. Is less than 8 more than the number. The number is n. 8 more than that would be plus 8. And here we have a variable on both sides. So I'm going to be canceling the one on the right side. I'm going to subtract n from both sides. N minus 5 is less than 8. When I add 5 to both sides, I get n is less than 13. And there you have solving inequalities.